We plug in our smartphone, and when we do this, the USB charger applies a higher force on a flow of electrons in the opposite direction. Electrons are pulled out of the cobalt, thus returning cobalt to its +4 state and kicking out the lithium ions. On the other side, electrons are forced onto the graphite, which pulls the lithium through the electrolyte and back into the layers of graphite. As you see, it's the exact opposite of the earlier reaction, which is why this battery is rechargeable. The lithium and its electrons move in one direction when you use the phone, and the opposite when you charge it back up. Okay, so now let's rewind and add a few more details of note. First, these two sides can't touch. If the anode and cathode were to touch, and if there were any lithium left in the graphite, the chemical reaction would accelerate uncontrollably and cause a fire, or often a small explosion. Thus, a non-conductive semi-permeable separator that allows the lithium ions to pass through is placed in the middle. And this electrolyte isn't an effective barrier because it's a liquid. The second thing to note is that the graphite and cobalt peroxide aren't good at collecting or distributing the electrons. Thus, a conductive copper layer is added next to the graphite, and a conductive aluminum layer next to the cobalt peroxide. These two layers, or sheets, are called collectors. Okay, on to third.